like where the calculations, you can stop the video and practice it. Okay. Um, so, but see what dimensional analysis actually means. Okay. So this, so I'm running this video here, and then we'll go to the iPad.
Welcome to dimensional analysis, aka the factor label method, a standard method for mathematically converting from one unit of measure to another unit of measure. Dimensional analysis provides a straightforward algorithm for solving a wide variety of problems involving unit conversions. In this video, we will look at some examples of dimensional analysis, how to set up the conversion, and then some practice problems of increasing difficulty. So a single measure can be expressed with different numbers depending on the unit being used. A simple example would be measuring the length of a line. You could use inches, and this line would be 3.50 inches, or you could use centimeters, in which case the line is 8.89 centimeters. The length does not change, but different units are used, and so the numbers are different. Let's say you have 36 donuts. You could also express that as 3 dozen donuts. There is no change in the amount of donuts, just in the unit used in expressing the amount. So we saw that 3.5 inches is the same as 8.89 centimeters. Let's take a look at how we can mathematically convert from one unit to another using what are called conversion factors, and seeing how they are used in the specific mathematical structure called dimensional analysis. Although most of the problems presented here are simple enough to do without the structure of dimensional analysis, we'll use them to show how to construct the setup of dimensional analysis, which will prove very useful down the road for more difficult problems involving multiple conversions. The first problem gives us the mathematical basis for the inches to centimeter illustration shown earlier. The problem gives us inches, gives the numerical relationship between inches and centimeters, and asks for centimeters. We will convert from inches to centimeters. We'll take a quick overview of what is involved and then go back and review each step. So what's the mathematical setup? Identify and write down the quantity given in the problem and multiply it by a fraction in which the unit given is on bottom and the unit wanted on top. Let's put the first term into a fraction to make it clear what units will cancel. With inches both on top and bottom, they will cancel, leaving the wanted unit, which is centimeters. The last step is putting the numerical relationship between the two units, which is given in the problem. For every 1 inch, there are 2.54 centimeters. The fraction is called a conversion factor. The answer is 8.89 centimeters. Setting up the conversion factor correctly is the essential part of dimensional analysis, which we will get to in a moment in more detail. So this gives us a generic setup for dimensional analysis. Unit given times the conversion factor, unit wanted over unit given. Mathematically, we multiply what's on top and divide by what's on bottom. Let's go back and review each step. Write the quantity given in the problem, and here we write it as a fraction to keep track of what's on top and bottom. Draw a line for the conversion factor, put on bottom the unit given, wanted unit on top, and then write in the numerical relationship between the two units. After canceling, you should be left with the unit wanted, and here we are left with centimeters, the unit wanted. Plug into your calculator, and we see the answer is the same as what our ruler tells us. To illustrate another way of setting up a conversion factor, let's convert centimeters to inches. Here we begin with 8.89 centimeters, multiply by a fraction with centimeters on bottom and inches on top. Fill in the numerical relationship given. Centimeters cancel, leaving the desired inches, and the calculation gives the expected answer of 3.5 inches. If we look at the two problems side by side, we can see why dimensional analysis works. The conversion factors can be reciprocals. You simply choose the one that gets you to the unit desired. The conversion factor on the left converts centimeters to inches. The conversion factor on the right converts inches to centimeters. They're both the exact same relationship, just inverted for the purpose of the calculation. And the conversion factors work like that because they are mathematical equalities. The donuts provide another simple example, converting donuts to dozen. Starting with 36, we convert with donuts on the bottom and dozen on top. The relationship is 12:1. Donuts cancel, we are left with 3 dozen. Let's apply dimensional analysis to something with several unit conversions in a single problem. It takes 14.5 seconds for you to run 100 meters. How many meters will you run in 0.0520 hours? Let's look at the conversion that will be needed. The problem already gives us the relationship of seconds to meters, but gives us a quantity of time in hours. So we need to get from hours to seconds before finally using the relationship given to convert seconds to meters. We know in 1 hour there is 60 minutes, and we know there are 60 seconds in 1 minute. Let's see how we can use these relationships in calculating the answer. We write down what's given in the problem, which is the amount of hours. And so the first conversion has hours on the bottom and minutes on top. The answer is in minutes, and we can use a conversion factor with minutes on the bottom, seconds on top, leaving us with seconds. Finally, we can use the relationship between seconds and meters given in the problem to convert seconds to meters. Seconds on bottom, meters on top. Fill in the numerical relationship given in the problem, which then gives the answer in meters. Note that with problems where multiple conversions are necessary, we can more efficiently write out the problem as a chain of calculations. The first calculation converts hours to minutes. The second converts minutes to seconds. The third converts seconds to meters. Let's try one more problem. Pause the video and see if you can work it out. Note that one unit relationship, that of grams and cubic centimeters, is given in the problem. You would also need to find the relationship of liters and cubic centimeters, which is 1 liter for every 1,000 cubic centimeters. So let's take a look. For the purposes of solving the problem, it might be easier to write out gold's density as 19.3 grams equals 1 cubic centimeter. We start with the amount given in the problem, 250 grams of gold. Note that 19.3 grams per cubic centimeter is not a specific amount. It is a unit relationship, which is used in conversion factors. We want to get to volume, so the density gives us a way to do that. With grams, the unit given on bottom, and cubic centimeters on top. Grams cancel. We now have cubic centimeters, which we can convert to liters. Centimeter cubed goes on bottom so that it cancels, liters on top. Fill in the numerical relationship, 1,000 cubic centimeters for every 1 liter. The answer tells us that 0.013 liters of gold will have a mass of 250 grams. I hope you can see that dimensional analysis is a powerful method for solving unit conversions. Click here for applying dimensional analysis to metric prefix conversion. Welcome to a quick and simple.
So I'm not going to run this, but you can also see how metric conversions can be. There are also conversions, and you can cancel one unit with another, just like we did for the density or the other. So it's basically done the same way. So you can stop this video, okay, and practice them is as good as practicing from the book. So there are other videos here regarding significant figures, scientific notations that you can watch. Okay, so I'll leave it to you with that. Now, let's practice some here, okay? Okay. Can you all see it?
27.
So just, move the zeros, move the point, how many times?
2 or 3.
3 times.
10, 3.
So this is a number bigger than 1.
Hour.
And so, and the zeros will remain because they're significant. The correct answer is 2.7000 10 to the power 3, 6 significant figure. That cannot change.
Mm-hmm.
And same for the next one.
4
0.0005. So the
Mm,
correct answer is this four significant figure. So 5.1 only on, so
5.1 times 10 minus 4? No? Oh, no.
to the fourth.
yeah, so your decimal, you are
Yeah.
moving the decimal place. How many times?
Okay, okay.
You
Four.
remove,
Oh,
you move
four.
this
4
point,
times. Move
right?
it 4 times to the right.
Right, and your is a number less than one, so -4. So you're moving to the right, right?
4 times.
5.100. So your zeros at the end are significant, but not the zeros at the beginning.
Oh,
So
okay,
5.
that I did miss those last zeros.
Yeah, because they're significant. It's
Okay.
like B, same as B. The trailing zeros are significant.
Okay.
Okay.
So the next one, D, is you have to round to 2 decimal place. So in order to do that, you put a placeholder, right?
Yeah.
So it's you have to keep up to 8. You look at the next number. That's a 9. So the correct answer is, one.
9
Yeah.
times
And if
10.
you want to, if you want to do it in scientific notation, there's 1.9. By 1.9, because the last zeros are not significant. It's too significant figure.
I have to go with
For E, I got 5.00 times 10 to the power of 2.
No, 10 to the power 2. How can then that means it's 500.
Ah, it's 3.
Yeah. So assume there is a decimal place, okay,
Okay.
and then move the decimal place 3 times.
Okay.
So basically, you're moving like this.
it. Mhm. Mhm.
Okay.
Okay.
Okay. And these are all getting recorded, so you can go back and look at them again. Okay.
Okay. And then
So this additions. So I said,
this
simplify. So you do the parenthesis first in
A.
A, and when you do the addition, you keep to how many decimal place? You keep to 2 decimal place, because 2.11 is 2 decimal place. So when you add or subtract, you keep to the least number of decimal places. Okay, and when you divide or key least number precision, and when you divide, you keep to the least number of significant figure. So there are 3 parts in this question. You do the parenthesis first, so you add up. So when you add up, see,
I see.
so I did the addition here, 7.945.
Mhm.
So I'm keeping that number. I'm not throwing it out. So, but I put underline. Okay, so the underline basically tells you that that is the size of the number, but I'm not rounding it. I'm dividing it then by 3.55, and I'm getting 2.238.
Mhm.
So that is 3 significant figure. So see, I have underlined under 3.
Yes.
So that's but I'm not rounding. Then I'm going ahead and adding 1.2. And when I'm adding 1.2, I have to keep to 1 decimal place. So the correct answer must be in 1 decimal place. So I look at the next number, that's a 3, so I truncate.
4. Mhm.
So, you need to go back and repeat this same again, okay? And once you get used to, then try newer ones. So the next problem was you add 3,700 and liter with 220 liter. So again, you have to keep the least significant here, or the one that is at the largest error. So I have to keep to the second place here, third in the 100th place, right? So the underline under 9. So that means I'll have to fill the rest
Mhm.
with zeros. So the correct answer is 3900.
Yes.
So what you need to do is to apply this, at the top, I have that in red, that when you multiply, divide, least significant figure. When you add, subtract, least number of decimal place. DP is decimal place. And parentheses has the priority. Okay. Now the next one is with exponents. So when we are doing exponents, okay, so the problem was this actually.
Yeah.
See, if you look at C, 10 to the minus 5, 10 to the minus 3. Now you are adding, and you really cannot add or have any idea of the number of decimal places unless until you convert everything to the decimal notation, right? So no power. Now that becomes very inconvenient because there might be 20 zeros and I'll easily miss them. So I'll keep the scientific notation. But when I add, I have to keep them the same. So either I convert both to 10 to the power minus 5 or both to 10 to the minus 3. Either is fine. And then what happens? Why? Because if you do that, then you can see that you can take a common factor. Okay, like if you see here, okay, so this is a common factor here, right? I can take common and then add things in the parentheses just like a regular addition. So in order to do this, then I chose to convert everything to 10 to the minus 5. You can choose otherwise, no problem. And that's on the top with the violating. So the first factor is 10 to the minus 5. I kept it like that. If you look at the second factor, it was 10 to the minus 3, right? So 10 to the minus 3, I can write as 10 to the 2 and 10 to the minus 5. So that's in the parentheses. So basically I broke down the power so that I get it 10 to the minus 5. So my number then is 5.89 multiplied by 10 to the minus 5. That remained as it is. But the second one is 251.2 multiplied by 10 to the minus 5. And then when you add, you are taking 10 to the minus 5 outside the parentheses. And so this is all we did for what? To get that thing in the parentheses that I can conveniently add, just like using the rules for addition. So if I apply the rules for addition, I have to keep to one decimal place because 251.2 is actually one decimal place. And so the correct answer is 257.1. You will see that I did the, with the red box, that is where I did my addition. Okay, to 257.09. If I round that, that comes up to 257.1, to one decimal place. And so the correct answer in scientific notation is 2.571, 10 to the minus 3. So sometimes these numbers can be very deceiving. So you might think of a different number like 3 significant figure based on 5.89, but that's not correct. Because the exponents basically took away some of the decimal places there. So the thumb rule is when you are adding, subtracting decimal scientific notations, okay, numbers with exponents, they should have all carry the same 10 to the power exponent. It can be anything. Now, if I want to convert that instead of 10 to the minus 5, if I want to do 10 to the minus 3, then you look at I did what I did at the top, okay? So if you look at the top in a violet, 5.89 to the minus 2, now I converted the 10 to the minus 5 into the 10 to the minus 2, 10 to the minus 3. I kept the second factor same, and then I took 10 to the minus 3 common. In parentheses, I have this number. I wrote the number in decimal notation, okay? And then I added them. So when I added them, there's 3 decimal place, there's 4 decimal place. You have to keep to 3 decimal place, 2.571 10 to the minus 3. And you see, this is the same answer that you got from the first one. So it really doesn't matter how you do it. If you do it right, you'll always come up with the same answer. So this is getting recorded. So that means you can go back and look at it again. And please do. Okay, please do, because it's not possible to write everything. Okay. So the recordings will be helpful. So please do and repeat that again. Now, if you look at the next one, so the problem actually look like this. So a D, I have two exponents I'm adding and dividing by another exponent. So when I'm adding, I keep to the addition rule, that is least number of decimal places. And when I'm dividing, I'll keep to the least number of significant figures. Okay. So let's do the parentheses first.
Mhm.
So
Okay.
again, the same rule applies.
Yeah.
So you have to basically convert them to only one, one kind of exponent. So I converted everything to 10 to the minus 12. Okay, and in the parentheses, I have that. If I write that in decimal notation, so see in the box on the right, I added them. 2880 plus 1.3. So if I add them, I get 2878, you know, um, 787. Okay. Now, because there is zero there, that means my last significant digit is here, right? So this is my last significant digit here. So I have underlined because I want to keep to the least precise, just like on my bucket of water and drop. I'm adding a drop. So I need to know how much fluctuation is there in the number. So that number is fluctuating, that 8, that underline. Okay, uh, so when you do that, did I say right? No. Basically, we have to keep to here. Right, the third, the fluctuating number. And so the correct way of expressing that is 2880. So this is actually equal to, this is actually equal to 2880.
Mm.
Or yeah. So basically I did nothing because of the error. And that is what I wrote there in the parentheses. Okay. And I did it round at that stage. Okay. I added everything together, rounded at the end. So always do the rounding at the end. So even though this is the number, I'm not using that. I'm going ahead but I'm keeping myself a reminder and putting underneath that what is the size of the number. I think okay, let me see. What I did might not be right.
How did you get the -9? This is 2.88.
Okay, I'll get to that. But first let me fix this. I
Okay.
think this is not right because
Yeah.
2.80 when I'm adding 1.3,
Mhm.
basically this is where my um, you know last significant digit is. That means I have to keep to that much. Okay, so I was right in putting it here. So if I do that, let's so that means this number is actually 2880. Okay, so that means, uh, so what I have here is, so I erase this one. So when you are adding this, your number, okay, so 2880 divided by that number, and then you can do the math. Okay, 2880 divided by 5.11 is how much? So that 3.1 really didn't add up. So 563,
One, 63.
is too thick. So we have to actually keep two, three significant figures. So it basically comes to, yeah. So we have to do it. I didn't have much space there, but leave yourself some space, okay? So I was teaching it as a different class. Uh, so, but is that clear to everybody?
Oh,
So just follow the step one by one, and every problem is different.
Yes.
Now that's true. I mean, yeah, life is sometimes hard, but you don't have to do too many of these, too many of these. But if you have to do, this is how you do it.
Okay, I got it.
Yeah,
Gotta
but
review
again,
it.
this is getting recorded. So what you do is
Yeah.
you need to practice. And and really at the very beginning, when you're learning this, learn it like in a disciplined manner. Don't jump step. Do all the steps that I said, and then you'll get used to it gradually. But if you keep changing the way you are doing it, then you get confused.
Mm,
Okay.
all right.
So like you see, number 5.
Mhm.
Or here number 3. Okay, so 1.53 kg you are adding to grams. Now you cannot add grams to a kg. You have to convert either both to grams or both to kg. Either way is fine. So here, I converted it to grams. So one five 1.53 kg is 1530 grams. And then you add 25 grams to it. So now if you look at 1530, the last significant figure is the 3. So that is the limit of your, accuracy. So when you add, you get 1555 grams, but you have to keep to 3 significant figure. And so the correct answer is 1560 grams.
Mm,
And you cannot do that unless you convert the units.
okay.
Yeah, I mean, like I said, a lot of information going in. So don't get uh, disheartened. Okay, give yourself the time. Give yourself time, practice it. And really you need to practice, like I said, 1 hour of lecture is 2 hours of a practice. So if I'm giving 4 hours lecture today, you have to put like 8 hours throughout the week. Don't do it in one day. Throughout the week, let's say put 2 hours every day. Okay, working out this, and then by the next day when you come, you will be all okay. Spread it out so that it doesn't become a pressure for you.
Mm.
Spread it out throughout the week. But this chapter needs a lot of practice because this is the very fundamental chapter, and you use that for rest of all calculations that we'll be doing. And these are the power laws that I was trying to search. Okay, that a to the power x, a to the power y is a to the power x plus y. Okay, so these kinds of become very convenient when you are, and also mental check when you're doing calculations on the calculator. Okay, that you have done it right. Uh, sometimes becomes a big question. Now, there's one more thing that we need to actually try and see that we are okay with it. So this is done I repeated that a little bit with more space. So that also you can look at. But let's try one thing. So let's try this on your calculator, okay? Um, let's say that simple. So how much is it in your calculator? Try that. Okay, you have to know your calculator, how to put the minus sign in front of the power. Okay, and also try the next one. Try the second one first, and then the first one. Maybe the second one will be easier. All right, let me see. What did you say? Your answer is
7.4 times 10 minus 1.
4 times 10 to the power minus 1.
Minus 1.
Why 7.4?
I don't know how I multiplied the bottom numbers and then I divided and I got 0.74, 335,205.
So
And
why do you decide on a 7.4? Because you're in a bad mood.
then
So it's a least significant figure.
it's gonna be 3.
So least significant figure. What is the least significant figure here?
Oh
So
no.
your significant figure is 3 significant figure. This is
Yes.
4, and this is 4. So your answer must be in 3 significant figure.
And
And same applies for the first one now. So first one, what is the number of significant figure in the top? Which
it's
is the
gonna
P?
be 3 as well. 3.
It will be 3 as well because the bottom one is 3, right?
Yes.
So now we do the math.
Okay. So what I got was 2.568 but then I don't know what to do with that answer.
Okay, 2.5. Okay, that is your number part, and then you have to make it to 3 significant figure.
Okay, so it's gonna be 2.57.
Okay, and what about the exponents? You can throw them out.
Okay. There. Oh, 2.57 times 10 to the 0.
Okay, 2.7 is too significant figure.
Ah, 5.
Okay, what is the number you are saying? Let's see. Let's give me all the digits. 5.6.
Oh, okay. So
Five.
what I got is 2.56849315.
Okay, so we do not need that much.
No.
So let me see. 5.625 divided by 2.19. 2.5684. I mean, that much is good enough.
Mm. Okay, I got
2.5685. If I write it, then it will
Oh,
five.
because of the 9.
Right. So, but I need up to this much.
let's do one.
And then what about the 10 to the power?
It,
You can use that in the calculator, or I for myself, like to keep the tens outside. So what is that? When I add this 5
Yeah,
and if division, there's a minus,
Mhm.
and minus of what? Minus of -6.
So it's going to be 10 to the power of 1?
Minus of -6.
Oh, minus my, oh, plus. So it's 10 to the power 11?
Right?
Oh.
So you have to be systematic. It's not about being right or wrong. You
Okay,
have to be
okay.
very careful. I cannot even make a mistake if I'm not doing it like writing the steps. I like to write the steps because it takes 5 minutes to do it, and then if I find out it's wrong, just because I'm not
Yes.
careful, you end up spending half an hour uh, on the problem just because uh, you try to jump a step.
Jump
Don't jump
in.
step because it's not worth it.
Okay.
yeah. Yeah, I want to do steps.
Yeah, go step by step always.
Okay.
So okay. Now here are some conversions. Ooh, we saw a lot of conversions, right?
Yeah.
Now this is a multiple conversions where even is both in the top and the bottom. Now, see, I'm trying to convert. If you look at the problem there, is 25.0 kg per meter cubed. And I want to convert that to pound per feet cubed. Okay, let me see if I have an email. Okay, quickly. Okay, nobody. So whoever in the waiting room hasn't emailed me. All right. So I'm guessing that person needs to be outside. Okay. So can you see my iPad again?
Yes, it's there.
All right. So see, how do you approach that problem? So I can convert the kg to pound, and I can convert the meter cube to feet cube, right? So we are arranging such that just like you did the dimension analysis for the hour, minute, and the videos that I have is basically the same. So I picked up. I've been given the conversion factor. 1 kg is 2.202 pound, right? I can use that. So with that factor, the first conversion factor is converting it into pound. But then there's a meter cubed. I need to convert the meter cube to feet cube.
Okay.
How can I do that? So you see, I can go from meter to feet. How I can go to meter to feet? I can go from meter to centimeter, centimeter to inch, and inch to feet cubed. Because these are the numbers I know. So I have to cube them, and that's it. So each of these numbers, like 1 centimeter to meter. So if I want to go from meter to centimeter, okay, or centimeter to meter, it's like the first step that I'm doing. meter cube to centimeter cube. Basically, using this conversion factor, 1 centimeter is equal to 10 to the power minus 2, right? And I cubed it. And for the second factor, so these are the factors here. So if you look at these arrows, uh, so these are the arrows. So I basically made these factors here, um, like inch to centimeter. So this is the factor, and then the arrows shows I'm using them in that problem. Now you do not need to do that elaborately, but as long as you're following the units and you remember to cube the or square the number. So here you need to cube the number. Okay, 2.54 need to be cubed. 12 need to be cubed. And these are exact numbers. So if you look at the bottom, these are, if I take that, then I would not do my calculations there. I'll come down, see the downward arrow. I wrote down the numbers fresh so that there is no ambiguity when I'm entering it in my calculator.
Mm.
Because that's very important that you do not make mistake. Okay, because most of the mistakes that come from this part is careless mistake, or so many numbers to type, you miss one. Okay, so I wrote down the numbers. I exactly know what I need to put in the calculator. I exactly know what my unit is, because that is what is left after I canceled. I see the circle, the pound and the feet, they are not canceling out. That means these are the two units that are going to remain at the end. Okay.
Okay.
So these are the two units. So can you see my arrow?
Yeah.
The moving arrow?
Yes.
Can you see? Okay, so that's the basically these are the two units that are remaining, and these are the numbers. Okay, so that goes into the calculator, but then you need to keep to the correct number of sig picking. Okay, whoever that is not writing the numbers. Right, not writing the name. Sorry. All right. So that's then there is another problem here, or the same one, kg per meter cube to pound per feet cube. So I did it again here. So you can watch this in the video, okay, then the recording.
Yes.
So there are other questions like 10 millimeter and 100,000 micrometer. Which one is bigger? So to answer this question again, we can only compare if they are in the same unit. So convert everything to meter. That's the easiest thing to do. Convert both to meter. So if I convert millimeter to a meter, now how do I do that? I know that milli stands for 10 to the minus 3. So 10 multiplied by 10 to the minus 3. Okay.
Okay.
Okay, 10 multiplied by 10 to the minus 3, that gives you 10 to the minus 2 meter. If you convert the micrometer, you are getting 10 to the power minus 1 meter. Which one is bigger, 10 to the minus 2 or 10 to the minus 1?
-1 would be bigger.
Minus 1 is bigger. Negative power, smaller the negative power, the bigger it is. That's the opposite. So 10 to the minus 1 is the bigger number. So again, when you are comparing, different things with two different units, you cannot compare unless until you bring them to same unit. Okay. So here is another question. A rectangular room has the following dimension. Is 11 feet by 10 feet by 8 feet, right? Calculate the mass of air contained in that room if the density of air is 1.9. So the very simply, because the density, you need the volume of the room. Okay, so volume of the room is in feet. So I need to go from volume in feet, you can see in reading, volume in feet cube to volume in inch cube. Okay, then volume in centimeter cube. And from there, I need to go to volume in milliliter. So many conversion factors, right?
Okay.
But you have the path. It's like making a building. Now, when you make a building, you have blueprint. And they are not simple because you want nice looking building, right? So more complicated it becomes. You have layers. You know one by one where to go where. So these are your steps. You calculate the volume in feet cubed, then convert that to inch cubed, because I know the conversion factor between feet and inch. You see, the next below is 12, 1 feet is 12 inch.
Mhm.
So just below here, so I'm losing the arrows. Hold on. Okay. So can you see the arrow? So here, uh, from volume in feet cube to volume in inch cube, and each of these converse factors are coming here, okay, in the next line.
Mhm.
So I have the volume, which is 11.0, 10.0, 8.0 multiplied, and that in feet cubed. And that volume feet cube multiplied by 12 cube by 1. And the units are inch cube by feet cube. So they are cancelling out. So that is the first conversion. Then the next conversion, you are doing 2.54 cubed. Okay. So, and you can see this line so that how the diagonal lines, so that how they're canceling. Okay, and finally, you know, you cancel all this. These are the numbers that are left. Okay, that goes into the calculator, and it's easy to see now. When you write down the numbers in one place, it's easy to see how many significant figures are there, and you can see it's two significant figures because of the arrow. That is because there is a number that is two significant figure. So the hardest part is to have that map in front of you. Once you do that, it's mechanical. Okay, and the correct answer is 47 kg. If you look at the next problem, so you want to, and this is a very common thing that we need to convert from kilometer to miles. We can Google it. Okay, but if there's no Google in your hand, then you do it yourself. So here we are converting 431 kilometer to miles. And I am given that 1 mile is 1760 yard. And I am given that 1 yard is 3 feet. And rest we are expected to know. So how can I go from kilometer to miles? So I have the map in front of me. So can you all see the map?
Yes.
Kilometer to meter, meter to,
Yeah.
so from meter to centimeter to inch, and this centimeter to inch is a very important conversion factor, because that was connect the foot pound system to the or MK system. Okay, uh, and so you write down what you know. We know that one kilometer is 10 to the power 3 meter. Those are in black ink. And 1 centimeter is 10 to the minus 2 meter. 1 inch is 2.54 centimeters. So you can see, follow the black ink. These are the numbers. But my units are canceling out. Okay, as I go along, and finally, I am left with miles. Okay, and I write down the numbers again. So these are the numbers that I need to deal with. and my unit is in miles. And what is my significant figure? So if I look in the numbers, the exact numbers, 12 is the exact number, 3 is the exact number, because they're defined. So my actual, I would not use any of these numbers. So my measured quantity is 431.
Okay.
And that is the significant figure. So my answer must be in three significant figure. Okay.
Phew, a lot of numbers.
Yeah. And the rest is you have to just multiply and now this, I know you are getting tired and I am tired. No, I'm seriously, because it's one day class. And I like to give breaks in between for this reason, because when you are doing this many math in one day, your mind kind of cannot work, even for simple things.
God damn.
Yeah. So that's why, I'm just going through, if you just listen to me, and don't bother about the math, but listen to the main points there. But go, these are getting recorded, so you can always watch them. But do watch them and repeat them again. Do it yourself as if you are doing it, and you can check back what I did. Okay, and see if something is not right. See where it went wrong. Okay. So convert 200 nanometer to millimeter. These are things that you have to do, like in 1 minute, like if you are working in a place. Okay, because and the conversion factor is easy. You go from nanometer to meter, then nanometer cancels out, and meter cancels out in the next step. Left with millimeter. Just use the numbers that you know, and finally keep to the correct number of CP. They're very systematic, and only thing that happens is errors. Okay, errors from carelessness or just overlook something. So these are, basically with areas, same kind of problems. You know, so uh, I am just, um, showing it to you because it is getting recorded, so you can see it. Okay, don't bother about doing it now.
Okay.
But again, same idea, two rules there for multiplications and divisions. Um, like you see, the cod sold at 12.98 pound per kg. Okay, that's the fees. Okay, and the machine reads in pounds per dollar per pound. So how do convert that? So and given the conversion factors. Okay, so so you have the pound. You have to convert the pound to dollar and the kg to pound. Actually, two-step conversion. But you have to follow the units. That when you are doing it, your pound should cancel out. You have to put the conversion at such a way that a pound should cancel out, and then and the kg should cancel out and give in pound. And see, I just wrote the conversion. I the one in ink is what I wrote first. I wrote the units and then I put the numbers. And you also do that. Write the unit first and see how the unit must be placed, and then put the number. If you want to do both the number and unit together, then I see students get confused. Okay. So when everything is empty, put the units and see that the units are placed properly. Okay, and then put the associated number.
Okay.
So these are actually we are practicing from uh, those liver text, exercise and books. Um, so you may not be given something like that, but one of my students brought this question. Okay, uh, that a hollow metal sphere, there's an outer diameter and there's an inner diameter. What is the volume of the metal? So basically, it's a thin sphere. So you have to take the outside volume, you have to take the inside volume, subtract, and get the how much metal there is in volume, and then you have the density, convert that to mass or something like that. So these are basically, but I'll not be asking you that kind of question. But this is where you need all these knowledge about units, and these are practical things that one has to do. So you like this kind of thing, calories. So we'll do that in the next chapter. So people who are like for this particular course, the food calorie or calorie to joules, we need to calculate because we need to be conversant with the energy. So we'll do this kind of problem in chapter 3. But again, the idea is still the same. You just convert the unit.